The topic of this video is collecting like terms. So it's about adding up all the things that are similar to each other, that have similar values to each other. So let's say you're running a heap of shops. You've got cricket shops, right? And in shop number one, the store sold, I don't know, 3 balls. Oh, that starts with the same thing. Let's say 7 sets of wickets and 5 pairs of shoes. Oh, 5s and S's, that's terrible. Okay, in the next shop, we sold 7 balls, 2 sets of wickets, and 3 pairs of shoes. And of course, in the end, we're going to add all these up. So we're going to make this one big long sum. And the third shop sold 2 balls, 4 sets of wickets, and 1 set of shoes. So collecting like terms is about adding up all the B's, like counting up all the balls, separate to counting up the wickets, separate to counting up the shoes. Of course, they have different prices. So what I want you to do is highlight all the B's. It's important that we include their sign. So in total, that's what the equals is. We've got 7, 8, 9, 10, 11, 12. We've got 12 balls, right? In total, we have 7, 8, 9, 10, 11, 12, 13 wickets. That's a 13, not a B. And how many pairs of shoes? Let's highlight those in another colour. I think I see 9 there, 5, 3, and another one is 9. So when you simplify by collecting like terms, which is what you're going to be asked to do, you're not actually finding an answer. We already know how much money we made. What we want to know is what we sold. So we're simplifying these 3 different sets of numbers into 1 set of numbers. Okay, we're still just writing expressions. We're not doing any kind of calculating. We're just counting here. So first of all, to get you started, you're asked to classify these as like terms or not like terms. So A is the same as A. Yeah, it is. X's are the same as X's, so those are like terms. Y is the same as Y. That's a like term. A and B are different. Those are not like terms. X times Y, is that the same as just Y? No, it really isn't. It's a completely different number in the end. A times B, is that the same as B times A? Let me think. 3 times 2 would be the same as 2 times 3. That's both 6. 5 times 4, is that the same as 4 times 5? Yeah. Those are like terms. If they're written backwards like this, like BA, because we're supposed to write them in alphabetical order, so it should be AB. If they're written backwards, we're still multiplying the same numbers together, so they're still like terms. C times D, is that the same as C? No. And X is not the same as X times Y, so those are not like terms. And another set of similar questions. Minus 3x squared y, 5x squared y. X squared y is like x times y. And they both have the same variable there. So those are like terms. AB squared is like A times B again, because B squared is B times B. This is 10 is B squared A, so that is B times A. Now, do these have the same values? What's the word? The same components. There's an A there, there's a B there, there's a B there. They are the same. This one here, AB squared, so that's like A times B, is it the same as B times A times A. Do we have all of the same components? Well, we have a B in each, we have an A in each, and then we have, oh, those are not the same. Those are not the same. So I know they're not the same because I'm multiplying different variables together. Q times R times S is the same as R times Q times S. Yes, those are like terms. Q times R is not the same as just Q times R. Let me sing a Q over there. Oh, that's a no. A, B squared, C. So A times B times B times C. A times B times C. Those are not the same. Okay, so recognizing whether they're like terms or not like terms is important when you're going to collect the like terms. Collecting like terms, the sums look a bit like this, and I want you to use a highlighter, so I'm going to photocopy this stuff for you so you can draw on it. We're going to highlight the F's in yellow, F, 7F, and 2F, and those two terms, which are both constants, the 8 and the 4, those are like terms because they're both constants. So then I'm going to count up the F's, 7 and 2, that's 9F. 8 and 4 is 12. And there's the answer. There's the simplified version. It says simplify by combining, and I've said collecting, same thing, by combining or collecting like terms. Let's do G. Let's get a green highlighter. We'll do the X's in green. And we always collect the sign that comes before. Plus 31y minus y. So I start with 10x, I add 4x, that gives me 14x. I've got 31y, taking y away, I am left with 30y. M, we've got our constant in blue, new colour for the Q's in yellow, and the R's we're going to do in pink. All right. So the simplified version is going to look like 10. How many Q's? Well, we've got 7 there, plus another 2, that's 9Q. Now, one of the reasons for colouring is so that I know that my simplified version, because I've got 3 colours, my simplified version should have 3 terms. Now, with the R's, I'm starting with minus 3R, and I'm taking another R away. So altogether, I have taken 4 R's away. I've got minus 4R. Don't be scared by that minus sign. You definitely, as long as you include the sign before it, you just think of it as a sum. Minus 3R, take away R, gives you minus 4R. And then you've collected the like terms. And that really is as hard as it needs to be. Let's try the last one just to be sure. 11b. Now, b squared is not the same as b. b times b does not have the same value as just plain old b. So the b's are going to be in pink. The b squareds are going to be in blue. And then I'm going to count them up. 11b, take away 2b, that's 9b. Minus 3b squared plus 5, so minus 3 plus 5, that gives me 2b squared. And that is the simplified version. That's as hard as it gets, simplifying. And when you simplify it, it was one of the steps. So you simplify your, it's not an equation, it's an expression. You simplify your expression, and then you can do the next step, which might be some solving or something like that. That's it. Have fun with that.